Welcome to Hoshizaki Technical Training. I'm your host, David Rivera. Today we're going to be talking about freeze up and the freeze up checklist. A freeze up is when the evaporator turns into a big block of ice, or the machine is running, fills up the bin, stacks up ice into the bin, stacks up ice into the evaporator cavity and freezes up the unit. These are the things that we talk about when we talk about a freeze up. Now here are 4 things that we need to look into to find what's causing our freeze up. Step 1 is assessing if the unit is clean or dirty. We're going to take a look at the evaporator and the components that are inside of the water compartment and make sure that none of them are scaly. If we show scale buildup on the evaporator, that's going to make the machine harder to drop the ice during harvest. So let's address the unit and clean the machine. Let's talk about step 2. Step 2, it's all about the water. We're going to assess the machine to see if it has the proper flow of water going to the unit, because a lack of water could cause a freeze up. Now there's 2 tests that we're going to go over. Number 1 is a fill test. The fill test is we're going to drain all the water out of the unit, start the machine up from empty, and the water valve energizes for 2 minutes. In those 2 minutes, it's going to fill up that reservoir and dump a little bit of water down the overflow pipe. If we never get water going down the overflow pipe, we don't have enough water in the machine. That's the fill test. To be able to do the visual test on the unit, first thing we need to do is make sure that there's no ice on the evaporator. Once we do that, then we can start the machine up. The first thing that energizes on that unit is the water inlet valve. When that water valve energizes, we're going to be looking at the water coming off the bottom of the evaporator. You're going to pick the evaporator all the way to the right and confirm from the front of the evaporator closest to you towards the back of the machine that we have a consistent amount of water. Once we figure that out, then we can move over to checking all the evaporators, comparing the one on the right to all the other evaporators, and they need to be the same. The same amount of flow in the front, middle, and in the back of the evaporator. If you find that you have more water in the front, very little in the back, more on the right and less on the left, we have a water problem, and that's what's causing our freeze up. Now that we assess the water on the machine, we can go into a couple steps to find out what's causing these problems on the machine. First step is to check the water valve. To be able to check the water valve, we need to create a measuring cup with a 5-gallon bucket and a 1-gallon jug. With the 1-gallon jug, we're going to fill the 1-gallon jug up with water. We're going to pour that 1 gallon of water into the bucket, and with a Sharpie, we're going to create a line on the inside of the bucket where the water line is. We're going to keep doing that until we have about 4 lines. Now we have a measuring cup. Well, a measuring bucket. And we're going to need a hose that runs from the outlet of the water valve over to our bucket. We're going to turn the machine on. When you turn the machine goes through a 1-minute fill cycle. When the compressor starts up, we're going to shut off the machine. We're going to have 1 minute of water in that bucket. Now, every unit has a water valve that's regulated for their machine. Our big 2600s, the water valves are regulated for 3.64 gallons per minute. Smaller machines are rated for 0.51 gallons per minute. So you will need to call tech support to find out what is the rating for your water valve. By knowing that and knowing how much water you collected into the bucket for 1 minute, you can determine if the water valve is letting enough water through. Now let's move on to the strainer. We're going to remove the water valve from the machine and check the strainer. If the strainer is dirty, we're going to clean it out, pop the water valve back into the machine and rerun the test. If we're getting more water, we corrected the problem. If we're getting the same amount of water, we need to keep looking for the issue on our machine. Now let's go over to step 3. Step 3 is checking your float switch. If your float switch is stuck in the closed position and never shows open, the machine won't go into harvest. What puts that machine into harvest is the float switch, and the board has a timer built into it, your freeze timer. It could be 50, 65, or 75 minutes. If the float switch is stuck in the closed position, the timer on the board will automatically put the machine into harvest. To be able to check the float switch, we're going to check it with continuity or with ohms. We're going to check it 10 times in a row. For continuity, when you raise it up, it closes. You drop it down, it opens. If it fails once, it's no good. For ohms, we're looking for the same value all 10 times. If you have 3 different sets of numbers every time that float switch closes, I would say it's no good. You should go ahead and replace the float switch. Now, we do have a float switch video on our website at hoshisakiamerica.com under technical training. Let's talk about step number 4. And step number 4 has everything to do with your bin control. On our KM models, we could have a mechanical style bin control, a thermostatic style bin control, or our new ultrasonic bin control. If the machine is calling for ice, the switch is going to be in the closed position. If the switch is satisfied, the machine is going to be in the open position. To be able to check these things, you can check it with continuity or with ohm value. If you're going to check it with ohm value, we're looking for the same number every time that switch closes. If we're checking for continuity, every time the switch is in the closed position, it beeps. When you rise it down, it opens. That's exactly what we're going to do. If it fails once, it's no good and it's going to need to be replaced. If the bin control doesn't shut the machine off, the machine is going to stack up ice into the bin, eventually making it into the evaporator section and freezing the whole machine up. Bin control is very necessary. We have a bin control video at hoshisakiamerica.com if you need any more information about the bin control. On the freeze up checklist, there's 35 items. We're going to start with 1, 2, and 3. Number 1, after defrosting the ice off of the evaporator, was the appliance leak checked? Step 2, were there any leaks found, and if so, where? Step 3, was there any refrigerant added to the unit, and if so, how much? All these questions are related towards the charge, because not having enough refrigerant in the machine could cause a freeze up on the unit. Now, anytime you're going to address the charge, we're always going to weigh in the refrigerant. Let's talk about step 4. Is the unit stacked? Is the problem coming from the top machine or the bottom machine or both? Any one of these scenarios could be happening on your freeze up. Now we're going to talk about steps 5 through 8. Step number 5 is the water line independent. Step number 6, does the unit have the correct water line size? The minimum requirement is 3/8 ID. Step number 7, what is the water pressure and water temperature going into the machine? Step number 8, does the appliance have a water filter? And if so, please fill out the information on the screen. The reason why water is so important during fill and harvest is because we utilize the incoming water to drop the ice during harvest. If we're not getting the proper amount of water, we won't get a proper harvest. Now let's talk about step number 9. The ambient temperature of the machine. Is the machine a self-contained unit or a remote? If the unit is a self-contained machine, we want the ambient temperature of the room. If the unit is a remote machine, we want the outdoor temperature. This gives us a little bit of an idea on how the machine is running at those temperatures, so we can cross-reference that information with our data performance sheet and get what kind of pressures that we should be seeing in that machine. Now let's talk about step number 10. Is the appliance or the float switch dirty? If the float switch is so dirty that it can't travel down, the float switch is going to be stuck in the closed position and the machine will max out in its freeze cycle, increasing the size of the ice and having a harder time to drop the ice during harvest. Let's talk about 11 and 12. Step 11. List your S4 and S5 dip switch settings, like so. Let's talk about step number 12. Is the dip switch number 7 on your control board? And is your control board a 2 Apple 7664-02? It looks like this board right here. Understanding these settings gives the technician, when you send over this document, a little bit more insight on how the machine is operating. Let's move on to 13 and 14. Number 13, is the cube guide in the correct position? Number 14, is your evaporator separators in the right position? Both of these things could cause the ice to build up in the evaporator, freezing the machine up. Let's talk about steps number 15 and 16. Number 15, is the thermistor mounted properly, tight, and insulated correctly? Number 16, is the TXV mounted properly, tight, and insulated properly? Both of these items could relate into a freeze-up scenario. Now let's talk about steps 17 through 19. All these steps are going to be taking place during the fill cycle. Step number 17. Does the water tank fill and overflow? Step number 18. What is your gallon per minute rate at the unit? Number 19. Does the unit utilize the refill? And if so, is it on? On machines that have a refill, you're going to find that the machine has 2 water valves, one at the top and another one at the bottom, which is your refill valve. Only bigger machines, larger machines have this feature. Small machines like this KM 515 does not have a refill. They fill only once. Now let's talk about steps 20 through 24. Number 20, is the hot gas valve energizing? Number 21, is the harvest pump time utilized? Number 22, is the hot gas valve opening during harvest? Number 23, does the water valve close completely when de-energized? Number 24, what is the length of your harvest? All this information is information that we need to understand to be able to help you diagnose the issue with your machine. Now let's talk about numbers 25 through 33. These are all going to be issues relative to the freeze cycle. Number 25, is the pump motor energized during the freeze cycle? And does it have the anti-slush feature activated? Number 26, what is the water-cooled condenser outlet temperature 5 minutes into the freeze cycle? Number 27, what is the length of the freeze cycle? Number 28, is the cube size consistent with the inlet and outlet of the evaporator? Now let's talk about 29. Is there still ice dropping when the unit goes into the next freeze cycle? Number 30. What is the ice drop weight? Number 31. What is the head pressure of the freeze and harvest? Number 32. What is the suction pressure during the freeze and harvest? Now let's talk about number 33. When the bin control is activated, did the appliance shut down within 15 seconds of the first 5 minutes of the freeze cycle? Now let's talk about numbers 34 and 35. Number 34. Has the freeze time correction been activated? The power OK light will be flashing. Number 35. If more than one freeze time correction has been activated, the power OK light is going to be flashing and the extended harvest light will also be flashing. Now that we have all this information, we're going to put it on the document of your freeze up checklist and you're going to share this document with tech support. Now we're going to be able to go over the document together and figure out what's causing your freeze up problem. Thank you again for watching Hoshizaki Technical Training. Today we cover freeze up and freeze up checklist. If you need any further assistance, please contact Hoshizaki Technical Support.